Welcome to Trigonometric Equations. Notice the heading of this slide. It says we'll be finding solutions in the interval from 0 to 2 pi. We'll be looking at a more general case later on in the lecture, but basically this just means we'll be looking at one revolution around the unit circle. First problem, let's find the solutions to the sine of x equals negative square root of 3 over 2 in the interval 0 to 2 pi. Now this problem will be very easy to solve provided we know the values on the unit circle. I'm going to pull up the portion of the unit circle that's relevant to this problem because notice it says that the sine is a negative number. Now in order to solve this problem, all we have to do is search the unit circle and find where the sine equals negative square root of 3 over 2. Well, we know when we have those unit circle coordinates that the sine is equal to the second, that is the y-coordinate. So let's see where we find that. Well, I'm circling here. I find it in quadrant 4, and I also find negative square root of 3 over 2 in quadrant 3. So the answer would simply be the angles corresponding to those two. So the solutions would be the angle 4 pi over 3 and 5 pi over 3. Now yes, we'll be looking at some problems today that will be more difficult than this one, but they usually do come down to having some knowledge of the unit circle. You might notice that this appears to be the same as the last problem. Sine x equals negative square root of 3 over 2. So let me just jot down those two solutions we found in the last slide. We found 4 pi over 3 and we found 5 pi over 3. Well, there is a difference because you see here it says let's find all solutions. Now we know the unit circle, if you go around once, you'll go 2 pi radians, but you can keep going. You can have 4 pi radians, 6 pi radians. Every time you go around another 2 pi radians, you simply have gone in a complete circle and you've ended up in the same position you were originally at. So I'd like you to notice that in both of these, it would be harmless for me to add 2 pi to either of them, or 4 pi, or 6 pi, or 8 pi. So what we're going to do is we're going to attach to 2 pi the number k, and what we'll say is that k is an integer. So if k is 2, we'd be adding 4 pi. If k was 3, we'd be adding 6 pi. Now integers can be positive or negative, and the fact is if you subtract 2 pi or subtract 4 pi, you also end up in the same location. So the only difference between finding solutions within 0 to 2 pi or all solutions is, are we looking at one revolution or more than one revolution? So as we do more examples, we'll just have to handle whichever case we're asked for. Well, notice in this one here that I have said that's just solved within the first revolution, 0 to 2 pi. Now we have sine on both sides of the equation. We have numbers, and I'm going to start doing this, just the way you'd solve a basic algebraic equation. That is, I could take away 3x from both sides of the equation. Not 3x, excuse me, 3 sine of x. So if I take away 3 sine of x from both sides of the equation, I'll have over here on the left 2 sine of x, cancel over here on the right. I'll still have minus 2, and I'll have equals negative 1. I could then go and add 2 to both sides of the equation, which would give me 2 sine of x equals 1. And finally, dividing both sides of the equation by 2 would give me sine of x equals 1/2. Once we've solved for sine, now it's just a matter, let's look at the unit circle and see where we can find where our sine is equal to 1/2. Sine is equal to 1/2. Again, sine is the y value, so we see a y value of 1/2 here in quadrant 1, and we see one also in quadrant 2. In the quadrants that aren't shown, the sign values would be negative. So we would have two solutions to this. We would have the angle pi over 6, and we'd have the angle 5 pi over 6. We would not have to add 2 pi in because we're just looking, as it says at the top, just one revolution. Let's have a look at a tangent. It says tangent x equals 0, so we don't have to do any algebra. It's already solved for tangent, so let's just have a glance at the unit circle and see what we're dealing with. Now, if the tangent of x equals 0, first of all, let's make sure we remember what tangent is. Tangent equals the sine over the cosine. So in terms of the unit circle, tangent will equal the y value of the coordinate over the x value of the coordinate. So let's look at our coordinates where we see a 0. We see, that at, for instance, at 0, pi over 2, pi, and 3 pi over 2. Top, bottom, right, and left. And let's just have a look at those. For 1 over 0, if we form the tangent, sine over the cosine, y over x, that'll be 0 over 1. That will equal 0. Oh, so that's good. The tangent's 0 there. So we have one of our solutions would be 0 radians. Let's look at the top here at 0, 1. Notice if you form the ratio there of y over x, you'll get 1 over 0. That's undefined. You can't divide by 0, so that would be no good. Over here, at the right, the correct ratio would be 0 over negative 1. Well, that equals 0, so that's one we want. And if you look at the last one, you probably realize it's like the one above it. If you form a fraction there, you'd have 0 on the bottom, and that's no good. That's undefined. So we just ended up with these two here, and so we have two solutions to that equation. All right, well, do things get any harder? Yes. Techniques from algebra are often used, and one of the most commonly used techniques would be factoring. So I'll show you this example where we'll need factoring to solve it. Sine squared x minus square root of 2 over 2 sine x equals 0. Well, notice that that has a common factor of sine x. So let's factor sine x out of the equation. Now, since the first term's sine squared, we would have sine x times sine x to get sine squared. And notice for the second term, all we'd need is that fraction. Sine x times that fraction would give us the second term. Now, in algebra, after we factor an equation, what we do is we take each factor and we set it equal to 0. So let's first take sine x equal to 0. And let's pull up the unit circle again because it'll come in so handy. Now, where does the sine equal 0? Well, sine is the y-coordinate, and so we find that that happens at 0 and at pi. So now let's go deal with the other factor, this second one. If we take that factor and set it equal to 0, we would first have to isolate sine by adding the square root of 2 over 2 to both sides, and we would get this. Okay, so now we're looking at where is the sine of x equal to square root of 2 over 2. Notice we would have it in quadrant 1 and in quadrant 2, and the angles there are pi over 4 and 3 pi over 4. Since we're just looking within one revolution, those would be all of our solutions. Let's have a look at another one, and this time I'll be general and I'll say let's find all solutions. We have an equation in cosine, and notice that drawing on your past algebraic experience, this looks a little bit like a trinomial, and let's try factoring it as if it were a trinomial. Now, to get the first term, 2 cosine squared of x, you would need to have a 2 on one of those. So it could be 2 cosine, and the other one would just be cosine to get the cosine squared. Now, to get that last term of -1, well, 1 times 1 would give 1. One of these would have to be a negative. Well, this is called trial and error. Let's try putting the negative first, the positive second, and if it doesn't work, we can go and erase those. So just check this. 2 cosine times cosine gives 2 cosine squared. And now, I'm foiling here. So now I'm at the outer, that would be 2 cosine x, and the inner, minus 1 cosine x. Notice 2 minus 1 gives 1 cosine x. So we've got it. And then finally, -1 times 1 gives -1. So guess and check is what some people call this method. So for the first one, we would have 2 cosine x minus 1 is 0. 2 cosine x equals 1. And cosine x equals 1/2. For the second one, we would have cosine x plus 1 is 0. So cosine x equals -1. And let's look at our unit circle and just pick out the correct angles. For cosine x equals 1/2, I see that in quadrant 1, not in quadrant 2. I do see it way down in quadrant 4. So it looks like we have pi over 3, and we have 5 pi over 3. And then for cosine x equals -1, I'll do this one in green. The only place you'll see that will be over here at pi. Now it does say find all solutions, and so this is where we would say then plus 2 pi k plus 2 pi k plus 2 pi k, where k could be any integer at all. Okay, so that finishes this lecture here. Good luck with learning the material.